Now we're going to learn about mutually exclusive or inclusive events. We actually saw both of these when we were looking at our theoretical probability, but now we're going to take a look at their official formulas and see some that might be a little bit more complicated. So first of all, mutually exclusive events are events that cannot occur at the same time. So for example, when you are drawing cards from a deck, you cannot draw one card that is both an even number and a face card. So those are mutually exclusive. And to calculate their probability, you simply add the probability of the two events. So when you're looking at probability, if it is and probability, you multiply because you're looking at one event and another both occurring. If it's or, you add because you were looking at one event or another occurring. For inclusive events, these are events that can happen at the same time. So for example, again, our deck of cards, if we're talking about pulling one card out of the deck that is red or 5, we can pull one card out of the deck that is both red and 5. So what happens when you add the probabilities together, the probability of red plus the probability of 5, you counted those red 5s twice. You counted them as red cards and you counted them again as 5s. So we subtract off that double counting, and that's what we've got at the end of our formula here. So we're going to start by taking a look at simply mutually exclusive events. These are the easier ones. This is when you simply add the probabilities together. So our first one is that example we just saw on the vocab, the probability that we get an even card or a face card. So the even cards in a deck of cards, of course, are 2, 4, 6, 8, and 10. And for each of those cards, we have 4, the hearts, diamonds, clubs, and spades. So we take the 5 even cards times 4 of each, and we got a total of 20 even cards out of our 52 cards. Or a face card. Well, the face cards are jacks, queens, and kings. And again, we have 4 of each of those for the 4 suits. So 3 times 4 gives us a total of 12. And because there are no cards in both lists, there's nothing that got double counted. So we have a total of 32 cards out of 52. Simplifying, dividing each by 4, we get 8/13. That is probably the ugliest 8 I've ever drawn. Next, taking a look at clubs or hearts. Can we pull one card out of the deck that is both a club and a heart? The answer is no, so these are mutually exclusive. There are 13 cards of each suit, so there are 13 clubs and there are 13 hearts, which gives us a total of 26 out of 52, which is half the deck. And our last example for the mutually exclusive ones, probability of 3 or probability of ace. Can you pull one card that is both a 3 and an ace? Nope. So there are 4 3s in the deck, hearts, diamonds, clubs, and spades. And there are 4 aces in the deck, same suits, for a total of 8 out of 52, which simplifies to 2/13. All right, next let's take a look at those inclusive events, those events that can happen at the same time, and see how this probability is a little bit different. So again, can you pull one card that is both red and 5? The answer is yes, so we will need to subtract when we calculate this probability. So red cards, well, you have all of the 13 hearts plus the 13 diamonds for a total of 26 out of 52 cards that are red. 5s, well, you've got the hearts, diamonds, clubs, and spades, so there are 4 5s, but 2 of those 5s are red, the 5 of hearts and the 5 of diamonds. So we have a probability of 28 out of 52, dividing each by 4, we get 7/13. Spade or a face card. Can you pull a card out of the deck that is both a spade and a face card? Yes, so these are inclusive events. There are 13 spades in the deck. We looked on that first slide, there are 12 face cards, the jacks, queens, kings, and there's 4 of each, minus the jack of spades, queen of spades, and king of spades. So there are 3 cards that we counted as spades and face cards. So that gives us 22 out of 52 Dividing each of these by 2 to simplify, we get 11 out of 26. And finally, diamonds or less than 4. And for our class, we're going to count aces as being less than 4. We're going to count them as a value of 1. So can we pull a card that is both a diamond and less than 4? Yes, so we'll have to subtract those. Again, there's 13 cards in each suit, so we've got 13 diamonds, plus the ace, 2, and 3 are less than 4, and we have 4 of each of those, so 3 times 4 is 12, minus the ace of diamonds, 2 of diamonds, and 3 of diamonds. So there's 3 cards that got counted twice, and this gives us the same probability, 22 out of 52, which simplifies to 11/13. And check out your 2 U-Try questions. First one is mutually exclusive, and the second event is inclusive.